Hey guys, Zong here, back with another math video. This one's going to be a bit of a short one, mainly because I just am finished with my first week of school and I'm really tired, and I'm sure you guys are too. But this video is actually just going to be a question I'm going to propose to you guys. It's called the circle packing question, and I can't take credit for this. My math teacher gave us this question, and the question basically asks, say you have a lot of cylinders that you want to bunch together. What is the shortest length of string needed to bunch these cylinders together for n cylinders? And after I propose this question, you can actually just send your solutions if you want to do them, and message Daniel or I or the Cyclic Squares Facebook page, or email us. And when it's my turn again, I will actually look at the solutions and see if any of you are right or got it. So the circle packing question basically says, okay, you have a bunch of cylinders, n cylinders. What's the shortest length of string you could use to pack them? So let's see what I mean by that. So we're going to do a top-down view of the cylinder. So this is the face, the circular face of a cylinder. And it's a top-down view. Imagine a bunch of soda cans, and you have one cylinder. And obviously, if you have, let's say, some string, and you want to pack this, it's obviously just going to be the circumference. So that's just going to be 2 pi r, right? It's just the circumference. So that's for n equals 1 cylinders, right? Now let's say you have another one. So n equals 2. And you want to have a string around them. And well, you can probably just calculate the length of the string in this case too. So there's a semicircumference here, a semicircumference here, so that adds up to a total circumference. And then you have these lengths, this length, and 2 of them. So if this is r, this is 2r, and both of these lengths added together is going to be 4r. Okay. Well, let's do 3. Just adjust my pen. So with 3, you don't want to go in a line like this. That's stupidly long. We want to bunch the circles together, so the string is the shortest distance, right? Obviously, this is probably the most efficient way, intuitively and trivially. So you don't want to put it here. You want to put it here, and then we can just look at the. If we can do the string again, it's going to be like this. Let's see if we can find the length of that string. So the length of the string is actually sort of weird. It's so we know this length is 2r, this length is 2r, and this length is 2r. And then what happens is this length is actually a third of this circle, a third of the circumference, a third of the circumference, and a third of the circumference. And since I don't want to give away too many hints and stuff, you can probably figure this out on your own, that yes, these are thirds of the circumferences, and I'm not going to prove it to you in case you want to leave that as an exercise on your own. So this adds to a whole circumference, so it's 2 pi r plus 6r. So already with n equals 1 through 3, we're getting sort of a pattern. Let's see if the pattern holds. I think with 4, the shortest one is like this, and actually you get 2 pi r plus 8r. And with 5, I think it's like this, and you get 2 pi r plus 10r. So there seems to be a pattern as you keep going on these trivial small cases, and maybe that pattern holds and maybe it doesn't. Here's a hint. The pattern doesn't hold, and we want to see why, and we want to see if we can have a generalized formula for the length of the string for n circles. So if you guys think you're up for the task, and you want to present a solution to Daniel I, or it doesn't have to be a full solution, it can be partial solution, interesting things you found, any thoughts you have, any questions you may have, just message us, and I'll go over this question 2 weeks from now. Alright, thanks.